Big surprise. There won't be any extensions on this homework, so make sure you get it done. When's it due?
September 9th.
September 9th. Better. What time?
11:59
11:59
p.m.
So don't start at 11, okay? Don't start at 11:45.
I recommend starting.
25 problems, you should be able to start at 11:30, right? Get it done?
That's Pacific Standard Time?
Yes. All right, so if you're having trouble, get help as rapidly as possible. If you're still having trouble with your calculator, you're running out of time, make sure that, what you want to do is just make sure you have some way of operating your calculator. And if you're having trouble with it, then you should find someone who has your same calculator, who knows how to operate it. And then write down a set of instructions on how to operate it, right? You get a page of notes for the exam. You could have instructions to how to operate your calculator on that page of notes. I don't look at it. So make sure you have a plan for how to operate your calculator correctly as you do the calculations. Any other immediate questions that have come up? Yes?
I'm a little confused on how the homework works. So if you get one wrong and you want to go back and fix it, but you don't want to do the entire thing all over again, every question, you can go back and erase it and write the new answer?
But you'll lose some points.
You lose some points.
Yeah.
Yes.
And then if you do that, you lose points, and then you go do the whole thing again, but if you get 100% the second time, then you get 100%?
Bingo.
Okay.
You got 3 chances. So the idea is to make yourself a set of notes and be able to get it right by the end of it.
Right.
The same answer at the end, you're not doing it.
Takes a little while, but you'll get used to it. It's not all that bad. All right, so we're going to move in and talk about some real basic physics ideas. And we're going to start off with motion, but before we start about motion, we have to talk about something a little more basic than motion, which is just position. So xi would be a reasonable way to designate initial position, a little subscript I there, initial position. Does that sound reasonable? Mm-hmm. All right. And x might be the final position. Doesn't have a subscript. If you want to put a subscript on it, it's absolutely fine. I'll just start off without a subscript on it for now. But I being the initial is the important one. And then we want to talk about what's most important to us, the change in position, which is just the difference between the final minus the initial. This is always final minus initial. And this gets a new name. We call this a displacement. Now, displacements can be positive or negative. Let's do an example. A couple of examples. Many examples. There we go. Come on. I'm going to give it to me. There we go. All right, so our character here starts at x equals 4 meters and ends at x equals 1 meter. What is the displacement?
3 meters.
She says boldly.
Negative 3 meters.
Negative 3 meters. Delta x equals x final 1 minus 4 is equal to negative 3 meters. So like I said, displacements can be positive or negative. Okay, displacements are a bit different than things you're normally used to. So how far did this person move to go from the initial to the final position?
3 meters.
The answer is, we don't know.
Oh,
Because we don't know what this person did. This person might have started at 4, gone to 5, and then gone back to 1. Or this person might have gone all the way down to 0 and come back to 1. We don't know how far this person traveled in going from their initial position to the final position. All we do know for sure is the displacement or the change in position. So all we know is that different distance between the initial and final displacement. Don't know anything about the distance. Okay, now we come to the word speed. Speed is a dangerous word because it doesn't have a really clear definition. In fact, there are 2 definitions of speed and they're different from each other. So whenever you see the word speed, you really have to make sure that you are understanding which definition they want you to use. So definition number 1. And this would be your common definition of speed. If you travel 40 miles in 1 hour, you've gone a speed of 40 miles an hour. Common definition. Then there's another definition which can be different. So the second definition, which we use most of the time, is just the magnitude of the velocity. So now that I've got that in there, let me define what velocity is. So the velocity is really just displacement over a time interval, or delta x over delta t for a better way of writing it. And because displacements can be positive or negative, velocities can be positive or negative. And so the second definition means magnitude means throw away any minus signs that you might have. When you see the word magnitude, all that means is throw away the minus sign. So that's just the magnitude. minus the velocity minus any minus signs that it might have. All right, let's do a couple more examples. Gonna go back to our character here. Here's x is equal to 0. And the person ended up at x equals 1. Start at x equals 4. Okay, so our person's going to start at x equals 4 at t equals 0. We're going to end there at x equals 1 at t equals 30 seconds. And now I'm going to describe the path taken. All right, that's how the person actually got there. They moved from x equals 4 to x equals 8, then to x equals 0, and then back to x, and finally to x equals 1. So sure enough, this person didn't take the obvious path. Okay, so question 1. With physics, we mainly deal with velocity. Velocity is always delta x over delta t. So let's calculate that. And we already know that this is x minus x initial. And this would be t minus t initial. We'll write this down as 1 minus 4 divided by 30 minus 0. The numerator we have negative 3 meters, and the denominator we have 30 seconds. So our delta x delta t is equal to negative 0.1 meters per second. Is there any surprise in all of that? Velocities are usually easier to calculate than speeds. But now, since we have this, we can just do this definition of speed. Okay. Using that second definition of speed, what is the speed of this particle, person, thing, object? It was a person, so it's a person, yes. So the speed is equal to 0.1 meters per second. By the second definition. See what I mean about magnitude, meaning just throw away any negative signs? And because we have definition number 1 there, let's try it by definition number 1. Speed number 1 being distance traveled. divided by time taken. And so now we need to figure out how far did this person move. So let's see, we're gonna add up each little segment. From 4 to 8 is how far? 4. From 8 back to 0 is, it's 8. Yeah, we don't, just adding up the distance, so we're gonna go the first 4 plus 8 more, and then up to 1? 9.
13.
So the person actually moved a distance of 9 meters.
How did that happen?
What happened to the first
Yeah,
one?
doing math early in the morning is, good question me, doing it in my head is always, so we got 4 to 8 is 4, plus 8 going back,
12.
is 12, plus 1 more is 13. There we go.
Yeah.
Keep me honest here. 13 meters in 30 seconds. Time happened to be the same. So we got 0.43 meters per second. Okay, so now that I've introduced this definition of speed number 1, that's the one that you should know about, but we really won't be using it. So you should know what it is, but you will not use this one.
Oh, number 1 is
Number 1 we won't be using, and I'm definitely not going to try to trick you on that one, so just don't worry about it. But I just wanted you to know it, so in case you're talking with somebody else, you'll know why you might be confused, because speed has 2 common definitions. This is the one that we will be mostly using. In fact, this is the one we will always be using. I'll go ahead and make that statement. Should be true. All right. Velocity. Can you remind me what velocity is?
The distance over time.
displacement over
Yep.
time.
The change of-
Time travel.
It's always displacement over time. And so it can be positive or negative. Now, truth in advertising, this really has another name. This is really called the average velocity. And there is, of course, another symbol for this. V with a bar on top of it, meaning average velocity.
Direction.
Hmm?
Is it because the velocity have direction as well?
No, the bar is just another way to express average.
Oh.
So, the average and the bar, that's just 2 ways to express that. That is the same thing as this. All right. So velocity is related to change in position. That seemed to make some sense? Yeah. What happens when the velocity changes? Probably true. But what happens when the velocity changes?
Acceleration.
Acceleration.
Acceleration is what you have when you have a change in velocity. Happy people, good. So these two are very similar to each other. If we can think of velocity as delta x over delta t, acceleration is just delta v divided by delta t. Or change in velocity divided by some time interval. And now we'll do a simple example. Okay, so our object starts at rest at t equals 0, and 2 minutes later, it has a velocity of 40 meters per second. Then we're going to ask you to calculate the acceleration. And you're going to say A is equal to delta V divided by delta T. Delta V is going to be V minus V initial divided by delta T. So our V is our final V. That's going to be the 40 meters per second. We got to subtract something and we got to divide by something. All right. What do we put in for our initial velocity?
0.
0, he says with confidence. How did he know that?
Oh, we don't. Starts at rest.
At rest.
Starts at rest, 0.
Starts at rest, yes. Very often you will have to interpret the words or know the common meanings from the words. So physics is a lot about word problems. Word problems with math. That's why we don't get a lot of takers. All right, so starts at rest. Yes, you would interpret this to mean the initial velocity is 0. Write it down like that. So we put a big 0 there. Our time interval. What do I want to put down for the time interval?
120 seconds.
Why would I put 120 seconds instead of 2 minutes?
Converting 2
Minutes
minutes to
per
seconds
second.
because seconds is standard SI unit.
Seconds is the standard in SI units. We've already got seconds here.
Yeah, so
That'd be
might as well put-
another reason to go ahead and just work in seconds. So because we already have it in seconds, 120 seconds, that is 2 minutes. That's our time interval. We can now happily divide, and we have our acceleration. Or 0.33 is equal to 0.333. And what are the units that I end up with here?
Meters per second.
Second squared.
Squared.
Meters per second squared, yes. Anyone tempted to cancel off those seconds? Don't admit it out loud. If you were tempted to cancel off these seconds, get help with your fractions quickly. Meters per second squared, yes. So the units of acceleration are meters per second squared. All right. With all of that. Here's one big important formula that happens to not be in the book. This is our position equation. And what it says is that the position is given by the initial position plus the initial velocity times t plus the acceleration times t squared divided by 2. It's easy to use. Let me demonstrate. Right. So here's our little story to go with it. An object starts at x initial equals 10, and it's at rest, and accelerates for 2.5 meters per second squared for a time of 45 seconds. Where is it? And so all you want to do is be able to take the information out of this sentence, plug it into that formula, calculate away, and you're quite happy. Give it a try, do something. Take a chance. Once you've figured out what you've done with it, then lean over and look at what your neighbor's doing and just laugh. Try to intimidate them. Make them feel small. Or you can be nice and say, wow, I like the way you did it. I did it all wrong. Anyone care to volunteer a number? We have a volunteer, 125. I haven't calculated it, so I don't know. 125, care to give me some?
135.
135, care to give me some units? What are the units of position? Meter, we're working in SI. This is a claim. She was kind enough to give us a claim. Anyone care to verify that or disagree with it?
2,541 as well.
Oh, I got. Yeah.
2,541.
0.25.
.25.
Yeah,
Sounds
I
like
mean-
the chorus is coming in on.
I saw.
There we go. Several people got that. Oh, need my units.
How you doing?
Okay. So, let's find out. Our x should have been our x initial 10 plus. What did we put for v initial?
0.
0. What are we going to put for the time?
45 seconds.
45. The units are already there. Plus 2.5 times 45 squared divided by 2. I don't have any units there because everything is already in SI units. And I find that otherwise units kind of make a mess, but I do make a mental note that I have everything in SI units. And we got 2,541.25. Meters, correct. Okay. Did you find out what you did wrong? Excellent. Okay. Any immediate trickiest thing about that? Pardon? What was the trickiest thing?
I said the placement, like
The placement.
of the acceleration t to that whole one.
That you have to square the t and get multiplied by the acceleration divided by 2. All right.
Those meters were
If I asked you to determine what the displacement is, could you tell me what the displacement is? What is displacement from your definition that was about 30 minutes ago?
Final position minus initial position.
Final position minus initial position, what would the displacement be?
2,541 meters.
31.
Final position minus
Oh.
initial position.
Oh yeah, the final position 2,541 minus 10 meters.
Bingo. So our delta x is 2541.25 minus 10, also known as 2531.25 meters. Just touching base with that idea of displacement. How did we calculate the displacements? Just get them on the screen at the same time here. How is this related to that? Pardon? We calculated a displacement. How does this calculation relate to that formula?
It's equal to a2 squared over 2.
Yes. Subtract xi from both sides. Then we'll have another formula. Not really a different formula, just a rearrangement. We have delta x is equal to x minus xi, which is equal to, I lost my v, v I t plus f over 2. There you go. Not really a different formula, just a rearrangement. See if you remember how to calculate what is called the average velocity. velocity is calculated from displacement. You know what the displacement is? Divide by the time.
Final velocity minus initial velocity.
More careful than that.
Plus v2 over 2.
What did we have from what you've done this morning? You know how to do it. We did it once. Got it in your notes. We just went over it about 20 minutes ago.
Is it 56.25?
I don't have a number, but we have a volunteer who's calculated a number 56.25.
That's what I got.
We've got a couple of people coming up with
Distance over
that.
time.
Distance, not distance.
Displacement over time.
Displacement over time, delta x divided by delta t, which is equal to R253.25 meters divided by 45 seconds. The right key is 56.25. And our units are meters per second. So hopefully that's not too surprising. Hardest part about this is that this isn't in the textbook. All right. So this is one of his few short failings, is that he just sort of starts off with physics in terms of this really weird looking formula. Well, it's not so weird, it's just, where does it come from? V final, let's see, we'll just write it in terms of this. V plus V initial divided by 2. That's where he starts, which is just, to me, it's always seemed kind of an odd place to start. And in fact, we can't even use it. We don't know anything about the final velocity.